Hey guys and gals, Mrs. Hoekstra here. Lesson 12 of Module 1. I'm on page 48. We're looking at ratios of fractions and their unit rates. Like I said, page 48. So the essential question I have already put in there for you guys. How can unit rates with fractions be applied in the real world? How can unit rates with fractions be applied in the real world? Right? Because I know a lot of students always ask me, well, when am I ever going to use this? Well, here's an example, okay? You have decided to remodel your bathroom and install a tile floor. The bathroom is in the shape of a rectangle. Okay, rectangle. Anytime I see a shape mentioned in a math problem, I usually kind of draw the shape just so I kind of get something in my brain to kind of get thinking about what I'm talking about. So there's my rectangle. And the floor measures 14 feet 8 inches long by 5 feet 6 inches wide. The tiles you want cost $5 each. Well, let's underline that. They cost $5 each. And each tile covers 4 2/3 of a square foot. If you have $100 to spend, do you have enough money to complete the project? Okay, that is the ultimate question. So let's box that question up. If you have $100 to spend, do we have enough money? So by the time we're done with this page, we're going to have to know, do we have enough money to be able to do this, right? All right, so let's make a plan, right? So I've got this chart here on this page to help us kind of figure out a way and organize our thoughts. Okay, so what do I know? Well, I know the dimensions of my floor, right? I know I have a rectangular floor and I know the dimensions. I know the dimensions of the floor. Well, let's keep talking about that. What do I want to find out about the floor? Well, I want to know that how much space it takes up, right? And that's called the area, right? I want to find the area. Okay, find the area. All right, how do I find it? So remember, area is all the space inside the rectangle, right? How do I find area of a rectangle? Well, I'm going to have to use the formula. Area is equal to length times width. However, I have a slight problem. I have 14 feet 8 inches and 5 feet 6 inches. I need to convert all that. I either have to put them all in inches or all in feet. I'm going to convert it all to feet. So I also need to convert inches to feet to be able to answer that area problem. Okay, well, what else do I know? Well, I know how big a tile is, right? I know how big a tile is. That's that green part that I have circled there. And I know the area, right? I know that a square foot of one tile, right? I know that a tile is, I know that part. What do I want to find out? Well, I want to find out the number of tiles. Well, how am I going to find that? Well, the plan is to take that total area that I'm going to have from the square above. I'm going to take the total area, and I'm going to have to divide by the area of one square tile. Right? I got to take, T-I-L-E, there we go, of one tile. But look at the ultimate last question, right? I want to know if I have enough money. So what do I know? I know how much it costs. I know the cost of one tile. Right? What do I want to find out? I want to know the total cost. Right? I need to know the total cost of this whole project. And how do I find it? Right? How do I find that? Well, I'm going to have to take my number of tiles, right? The number of tiles that I need, number of tiles, and multiply it by the cost per tile. All right, so there's my game plan. Because I know sometimes when we're doing math problems, it's kind of hard to know, like, where do I even start? So let's start with that whole first row going across. right? Let's start with that. So I'm actually going to put a number 1 by it, so you know I'm starting here. All right, and then I'm going to put my work for that whole section down here. Okay, so what do we have? Well, I said ultimately I've got to convert my inches to feet. All right, so I'm going to take, what was it up there? I'm going to take the 5 feet 6 inches. And I want to convert all of that into feet. Well, 5 feet stays, but 6 inches, right? How much of a foot is that, right? That's 6 over 12 or 1/2, right? So this is really 5 1/2 feet. Okay, let's do the same thing for the other dimension. The other one is a little bit trickier. We have 14 feet 8 inches. Well, how many inches are in a foot? Yeah, 12. So we're going to convert this into 8 over 12, right? 8 inches and 12. And then let's reduce that. And that reduces to 2/3, right? Because I can divide both the top and the bottom by 4 and I get 2/3. So this is 14 2/3 of a foot. Now, go back up to the top. I've done all my converting, but I have to find the area now. Area is length times width. So I'm going to take my 2 dimensions that I just converted. I'm going to take 5 1/2 and multiply it by 14 2/3. You have an ABC button on your calculator, so you would type in 5, hit the ABC, type in 1, hit the ABC again, and hit 2. And it's going to look kind of weird on your screen, but it will give you 5 1/2. Then you're going to hit times. Then you'll type in 14, hit that ABC button, 2, hit the ABC button, and 3. And that will tell the calculator that you've got these mixed numbers. And then you just hit equals. All right. Or if you don't have a calculator with an ABC button, you can convert these into improper fractions. You do 2 times 5 on that first mixed number. 2 times 5 is 10 plus 1. That's 11. And you always put it over the denominator. And you could do the same thing with the other one. 3 times 14 plus 2. And you get 44 over 3. Okay, so you can do it that way as well. When I do that, I end up getting 242 over 3 when it's simplified, also known as 80 2/3 feet, square feet, right? I have done all of number 1. You're like, wow, that's a lot of work, Mrs. Hoekstra. Yeah, real world problems actually are a lot of work. Okay, number 2, I do know the size of 1 tile, right? I know how big 1 tile is. What did it say up there in the problem? It said that the problem 1 tile was 4 2/3. So I'm going to take my area, 80 2/3 square feet, and I'm going to divide by one of those tiles, 4 2/3 square feet. This is going to give me how many tiles I need. Okay, well, I kind of liked having that mixed number, so I'm going to grab that mixed number from up above. 242 over 3 all over, and I'm going to convert 3 times 4 is 12 plus 2, that's 14 over 3. Okay, now remember, we've done problems like this before, so this is 242 over 3. When dividing, I actually multiply by the reciprocal. I flip that other number, so I'm going to do 3 over 14. All right, when I do that, I get 242 over 14, which can also still be reduced because I've already done one reduction, but I'm just going to convert this, and this is 17 2/7 tiles. Now, if you go to the tile store, right, you go to Home Depot, you go to Lowe's, one of those places, and you're going to buy tiles, you're not going to walk in and say, I need 17 2/7 of a tile. All right, the guys there, gals there are going to look at you like you're crazy. So how many do you actually have to order? Now, I know normally we would round down, but I need 2/7 of a tile. I need to have that little fraction of a tile, right? So I actually need to buy 18 tiles. Right? I can't round down. This is when in the real world you don't actually round down. If I round it down to 17, I'm going to have this little chunk on my floor that's not covered, and that's going to look weird. All right, last thing we're going to do is part 3. Now we just got to figure out, do we have enough money? So I know that I'm buying 18 tiles, And I know that a tile, right? I know the cost of the tile is $5. So I grab my handy dandy calculator and I type in 18 times 5 and I get $90. All right, so I've calculated the cost. Ultimate question, do I have enough money for this project? I do. I have enough money. How did I know that I had enough money? Because $90 is less than the $100 that I have to spend, right? I know that. Okay, go over to the next page and you're going to see an exercise. Yeah, every time I've gotten to an exercise, what have I had made you guys do? I make you pause the video because I want you to try this. All right, now before you hit pause, let's talk about it. We have a blue car and a red car. Let's say, you're out car shopping and you want to get a car. You want to know which one has the better gas mileage, right? Because, gas is expensive and you don't want to have to spend a lot of money on gas. And let's say the price of the car is the same. Okay, so price is not an issue. Which of these two cars will let you go further on 1 gallon of gas, right? Which one's going to give you more miles per gallon? That's what I'm looking for. So I want you to figure this all out, turn this back on, and check to see if you got the same answer as me. All right, so here's all my work for the two cars. And of course, I did the blue car in blue and the red car in red, right? So I converted 18 2/5 to 92/5, and then I converted the 0.8 into 4/5. All right, you could have left it the way you did, right there as is, and had your calculator do all the work for you. When you calculate it for the blue car, you end up getting 23 miles per gallon, MPG. The red car, again, I converted everything over to 87/5 and 3/4, and then did all of my math that I've been doing throughout this unit, and I got 23.2 MPG, miles per gallon. So that tells me that the red car goes further on a gallon of gas, right? It went 0.2 miles further. So if you're looking at the cars, they're the exact same car. Everything about them's the same except for the color and their miles per gallon. I'm going to take the red car, even though I like blue better. So hopefully you guys got that right, and I look forward to seeing you all in class. See you later.